Welcome everyone to the fourth and final lecture in Noam Chomsky's lecture series here at UCLA. Before Noam starts, I just wanted to make a couple of brief announcements. First, I wanted to acknowledge the support of the Dean of Humanities and his discretionary fund to help support this visit. I also want to acknowledge two graduate students at UCLA whose idea it was to invite Noam to come and speak to us, and they actually made the initial move to invite him. One of them, I think, is here, Richard Stockwell, wherever you are. Oh, there you are, right, okay. And Nikos Angelopoulos, who unfortunately had to go back to Greece to finish his dissertation. But we'll be taping, we're taping these, and he'll be here in spirit. Finally, I thought I would just share a little piece of trivia that I learned today, and that is that Noam has a bee named after him. Do you know about this? Yeah. It's called, let me get this, Chomsky. And it was discovered in Texas in 2013. So now you're all in possession of the same trivia. Without further ado, please welcome Noam for his final lecture.
I never did find out whether it's a honeybee with a waggle dance, but I hope somebody will find that out for me. Well, this has been pretty sketchy, especially yesterday. There's lots of loose ends that ought to be tied up. I think it would be best maybe to delay that to the discussion period tomorrow. So I hope you guys will come in with lots of questions and objections, and we'll be able to see if we can fix up what wasn't done properly, of which there's a lot. There was actually one question that came up in the question period yesterday about an important matter, and I didn't actually give the right answer to it, so let me go through it here. If I can get this to work. This one?
Others? Oh yeah, here's the black and the red.
Like
The red might show up a bit better than the green.
Okay.
Try that. If not the black.
Try this. So the paradigmatic example that I was giving about what distinguishes the legitimate from the illegitimate ones, you can illustrate it with parallel merge, the thing that people tend to write like this, where you have set A, B, C, this is the workspace, and then you would join this to this, and that's supposed to give you this thing, which in fact gives you the set A, B, and the set B, C, and this one becomes illegitimate because you can explode this to something as complex as you like, and since this is accessible, you can move that to there. Then you have a chain connecting these two things, which can violate all conceivable properties of language, so that's illegitimate. The argument that it is illegitimate is it adds two instead of one accessible terms, namely this one here and this one here. And you're only allowed to add one in the minimal system of resource control. So the question was, well, why doesn't this block ordinary IM? So suppose you have A, B, and you add this guy over here. Now you have B, A, B, ordinary internal merge. Why can't you do the same thing? Turn this into X, add this up here, and then you get the same problem. If you think about it for a minute, which I didn't when the question was asked, this turns out to be a case of late merge. What you're doing is trying to tack this into something that you've already passed. And that doesn't work for the reasons I discussed last time. Late merge, first of all, adds too many new accessible items, and then it also requires an extra operation of substitution. So it's the worst case of illegitimacy. So that one's out. The difference is once you've passed a certain point in the derivation, you can't go back and do something to what you've passed. But that a problem doesn't arise in the parallel merge case because these two guys are separate and nothing is protecting the thing that you moved from. So that makes the right distinction. Well, there are a lot of other things that need to be clarified, but instead of that, I'd like to turn to something else and at least touch on a few other things briefly, just to bring them up. I won't be able to go into them in sufficient detail. One point is that in addition to the symmetrical operation merge, there's quite good, in fact, I think completely compelling evidence that we also need another operation, an asymmetric operation, in addition to merge. This is clear intuitively simply from simple adjuncts. So, for example, if you have a phrase like young man, there's an asymmetry between the two that's clear. That element that's formed is a noun phrase, not an adjective phrase. So the old is an adjunct that's not changing the category. Notice this is quite different from symmetrical merge. In symmetrical merge, if you happen to have a head and an XP, then the head will in fact be the label, the thing that traditionally projects. But that's just a case of minimal search, and that doesn't work for adjunct asymmetry. So if you have old portrait of John is not a head, it's complex, could be arbitrarily complex, but it's still the label of the whole unit. So there's a clear asymmetry. Beyond that, there's a problem that's been lingering for 60 years. It's a serious problem. It's the problem of unbounded, unstructured coordination. So if you have something like the guy is young, happy, eager to go to college, tired of wasting his time, endless number of possible adjuncts. There's no structure among them. They're strung together, they're unbounded, and that's a real problem. For one thing, you can't do it in any kind of phrase structure grammar because you'd need an infinite number of rules. That's even true, interestingly, of the universal case, unrestricted rewriting systems, the ones that allow you to do anything, rewrite anything. You'd still need an infinite number of rules. Notice that unrestricted rewriting systems, as was proven by a great mathematician, Emil Post, long ago, are universal. Those are universal Turing machines, in effect, which means you can code the right result by some devious means, but you don't get it by just rewriting the rules and looking at the structure. So that's out totally from phrase structure grammar. About 60 years ago, when George Miller and I were working on mathematical linguistics, we thought we had an answer to this in terms of generalized transformations, but Howard Lasnik pointed out that that doesn't work either, so there's no method around, no device around that allows this. However, it is allowed immediately simply by the device of asymmetric pair merge. What we need is a new device, and since we're trying to get the simplest possible operations, the simplest operation after simple set formation is just pair formation. So we need an operation pair merge, which will also apply to the simple adjunct case like young man. Young will be adjoined to, will be attached to man, but you don't see it in the labeling, okay, because it's often some other dimension. And the unbounded, unstructured cases show you, in effect, that there are unboundedly many dimensions to what's going on up there. It's not two-dimensional like a blackboard. You can add any number of adjuncts at any point. So we want we want to work this out. That means intuitively that every member of this coordinated construction, every individual member of it is individually predicated of what it links to. Now, we know that the order of the unstructured, unbounded elements, this sequence, we know that the order of it matters. It matters because of reasons that were pointed out by Jim Macaulay about 40 years ago, namely notions like respectively. So if you say John and Bill saw Tom and Mary respectively, the order in which they appear affects the semantic interpretation. So it's not just a set of paired things, it's a sequence of paired things. Furthermore, the more evidence that it's a sequence is that adjuncts can repeat. So you can say the guy is young, tall, happy, young, eager to go to Harvard, so on and so forth. You can repeat them as much as you want. So what we have is a situation where, in order to generate these objects, you generate a set, finite set. You pick out of, you form from that set a sequence, and it could be any sequence of elements, and there's, in fact, infinitely many possible sequences. You pick one out of those, and that sequence, S, call it, is the thing that you're then going to merge into the construction to proceed with the interpretation. This operation of picking a particular element out of the set of sequences is, there's formal ways of doing it which are familiar. Those of you who know some logical recognize that this is David Hilbert's epsilon operator, which picks a single thing out of a set. It was part of his work on foundations of mathematics, basic operation. So it's a straightforward operation, but it does have the property that it's indeterminate. Okay, so it's that's part of the nature of production, as I discussed last time. Well, what this means is actually there's clearly two kinds of coordination, conjunction and disjunction. So what we're doing is forming objects that look like this. We're forming a sequence which begins with some conjunction and then contains a sequence of elements, each of which is predicated of something. So we have things, a sequence of things that look like this with a link. And in fact, we could say L1, Ln, but in fact, all the links have to be identical. One of the aspects of coordination is you're joining everything to the same point. Okay, so we can, and the same with all the ones through. So we have an object like that. That's the basic object that gives you unbounded coordination. When you get down to just one case, when n equals 1, that's just plain adjunction. So the old young man and so on. Now, notice that each element of these pairs is inaccessible. So if you have the phrase old man, say, you can't extract man and leave old. You can't extract old and leave man. So the elements of the pairs are inaccessible. And if that were all there was to it, notice that this would yield both the coordinate structure and the adjunct island constraint. You have the coordinate structure constraint because every term is inaccessible. You have the adjunct island constraint because you can't pull the things out. However, it's not quite that simple, in fact, as I mentioned earlier a paper by Željko Bosković, which shows that which just reviews lots of different kind of complicated cases. There are languages in which you can extract you can't extract anything inside the adjunct. There are others where you can extract something that's inside but not the adjunct itself, and a couple of other cases. So there's more work to be done. And what it in fact shows is that that the concept of adjunct is just not sufficiently refined. There's a number of different kinds of adjuncts which behave quite differently, and this is in fact kind of an unexplored domain. It hasn't been looked at sufficiently, but here's a major research project, is to ask how can we deal with the class of cases that Bosković left unexplained in his bringing together the two kinds of mysteries. They're still there. So here's a first step in how to capture it, but more has to be said. Well, the next question is, what is L? What do you link things to? So let's take the simplest case, say noun phrase and verb phrase coordination. John, Bill, Tom, the young man, et cetera, read the book, walked to the store, so on and so forth. What's the linking in those cases? Well, the assumption that comes to mind right away is that, say, and incidentally, I should say that I'm going to assume here that nominal phrases are actually NPs. The DP hypothesis, which is widely accepted, was very fruitful, led to a lot of interesting work, but I've never really been convinced of it. I think these things are fundamentally nominal phrases. Actually, there's a very good paper by Masa Oishi, who's here, who kind of spells out how this could work. This would mean that, say, in a nominal phrase, things like definite articles are actually features of the nominal phrase. They're not elements merged into it, very much like Semitic, where it's just a feature of the nominal phrase, and the definite article appears in every element of the nominal phrase, including the determiner. That seems to me probably the way it works. As far as determiners are concerned, like say that, I suspect they're adjuncts. So I'll be assuming that the core system is basically nominal. As I say, Masa's paper spells a lot of this out. So one suggestion you might have is that L is just N, but that runs into an immediate question. If you accept, which I am accepting here, the Chagit Borer, Alec Morant's theory of root categorization, which I think is pretty strongly motivated. You have the roots in the lexicon are independent of category. They become nominal or verbal, adjectival, by virtue of a categorizer that attaches to them. And incidentally, that would surely be pair merged. So pair merges to them, and it's probably it has to be the first operation in forming a derivation. You first attach the root to the category to the root, and you sort of go on from there with a pair merged element. But that element, say N for a root that's going to become nominal can't be identified with the n that is the link here, because this one is just much higher up in the syntactic object that you're constructing. Same with verb. It means that the small v, which is the categorizer, which is linked to the root by pair merge, can't be the same as what we call small v, or small v star, high up in the derivation. And in fact, I think that things like v and v star have been somewhat misinterpreted. They're not really it's not really a verbal categorizer, it's basically a phase marker. And I think we should think of both n, what we've been calling, or what I'm now calling small n, and we used to call small v, as being basically the two kinds of phase markers. I think a kind of natural way of capturing this is to go back to a classical distinction. Actually goes back to classical Greece, which has been used sometimes in generative grammar, and to assume that we really have two fundamental notions. Classical terms, they're the notions substantive and predicative. Which gives you 4 categories, plus S minus P, which is nominal, minus S plus P, which is verbal. And in classical grammars, that's all there is. So if you look at the classical Greek grammars up till late into the Latin, the Roman period, those are the only categories. There's no adjectives. Adjective we can add, but we'll consider it a non-primitive category. It would be both substantive and predicative. And then there's, of course, the fourth one, which is neither. And that's the rest of the junk that's lying around, prepositions and so on and so forth. But the two major categories, the ones that really count, are probably the ones that are the perfect substantive and the perfect predicate, the ones from essentially classical grammar. And there is some, and these are distinct from the categorizers, N and V. Those are totally different notions. And these things then would mark the phases, and it's kind of striking that, and they would be the links. All of these would be the things that coordination, conjunction, disjunction link to. Notice that there's a well-known phenomenon about extraction that holds of both nominal phrases and verbal phrases. There are some nominal and verbal phrases which resist extraction. You can only extract to the edge. You can't go out of the element. So we'll call those strong. In the case of verb phrases, it's the transitive verb phrases, the ones that usually marked V star. Those constitute strong phases that you can't move out of. You've got to first go to the edge, then you can go on. The weak phases, say unaccusatives, passives, you can extract all the way. And there's the same distinction in nominal phrases. So the complex noun phrase constraint, it's been known for a long time. It works strongly for definites, but not for indefinites. It's non-specific and specific. So extraction out of a definite noun phrase violates the rules. Extraction out of an indefinite, non-specific one is pretty straightforward. So it looks like both the nominal and verbal phases have the category, break into the categories, say, strong and weak. What we're calling V and the two types of flavors of V and V star, are probably just strong and weak phase markers, perhaps framed in this system. There is another. There's been a lot of discussion over the years about whether noun phrases are really phases like verb phrases. And one problem about it was that they have a lot of similarities, but there's one notable difference, and that is you don't have an escape hatch in noun phrases. There's nothing that allows you to go to the edge and then go on. But fortunately, as I learned a couple of weeks ago, there's a nice African language called Buli, which does have an escape hatch, has a marker that says, okay, if this is here, we can add on to the noun phrase and then go on. So if we simply assume that the basis for all languages is Semitic, Proto-Semitic, and Buli, then everything works out. So we're off and running. Just have to find the right languages. Other languages, like, say, English, are defective in this respect. They don't have that extra morphological element. It's one of the nice things about doing comparative work. You can fill in the blanks that ought to be there. Well, if you play with this, you'll notice that it can get pretty complicated. So, for example, it could be that one of the conjuncts, say S0, the third element in the sequence, it could, if this is a conjunction, the third one could be a disjunction. Okay, you can stick a disjunction inside a conjunction. And that disjunction could be an unbounded, unstructured element. And if you play with it, it gets very complex. I'll put that aside. The principles for dealing it are straightforward, but the actual working it out becomes pretty hairy. But it's not a fundamental problem, just a technical problem. Now, there is a fundamental problem, which was made very clear by recent work of Barry Shines. I don't know if he's around here somewhere. But Barry has a very terrific book, a great book that every semanticist ought to study carefully, which I think is the longest book with the shortest title in the entire literature. It's the book called And, 600 pages of details about the extreme, intriguing complexities that you get in the semantic interpretation of coordinate structures. It's all done in a kind of an event calculus, Neo-Davidsonian event calculus. So here's the task. The task is to take, assuming that this is the right kind of syntactic formalism, you might play around with it a little, assume that if this is correct, how can you go to from this to those semantic objects, okay? I'll come back later, if there's a little time, to the nature of these semantic objects, but I think he gives good evidence that that's the kind of target that the mapping from syntax to formal semantics is trying to achieve. So here's a huge unsolved problem for those of you who are looking for dissertation topics, one of many. And fortunately, there's lots of such topics hanging around. I should say, incidentally, that this is a dramatic difference from, say, the 1950s and even the 1960s. At that time, it looked like there was almost no topics. It looked like this whole field was finished. I think I mentioned this earlier. And one of the really striking things that's happened during my lifetime is that the field went from one that was terminated to one that's entirely endless and open. Everywhere you look, there's just more problems. That's a good sign that at least something's on the right track, because that's the way things ought to be. You know. People who are just coming into the field now probably aren't struck by the dramatic difference, but if you look back, it really is dramatic. Well, Another case that's an intriguing one is, let's see how to bring this in. Well, that's probably too complicated to go into. I'll skip this. Well, there are lots of other, there are plenty of other candidates for pair merge. Some of them are interesting unsolved problems. So, for example, if you take the paradigm, things like Mary saw the man walking down the street, say, or Mary saw the man walk down the street. You run through that familiar paradigm. You notice that there's a gap, a strange gap in it. With the bare verbs, like Mary saw the man walk down the street, you can't passivize. So you can say, the man was seen walking down the street, but not the man was seen walk down the street. This holds for two categories of verbs, perception verbs and quasi-causative verbs like make or let. You know, so I made the guy walk down the street, but not the guy was made walk down the street. Those two categories. This has been a kind of a funny sort of gap for a long time, no good explanation for it. There is a proposal, an interesting proposal by Norman Richards in terms of his contiguity theory, that it has to do with the output of passivization, but that doesn't work because the same problem arises with in situ passives. So kind of a little awkward in English, normal in most languages, but not bad in English. If you say things like, there were seen walking down the street 3 men, let's say, that's more or less okay. But if you try, there were seen walk down the street 3 men, that's hopeless, okay? So there's a sharp distinction between passives and non-passives, whether or not you move the object. Okay, so that can't be what's involved. So what could be involved? Well, what could be involved is kind of suggested by the fact that this holds for the quasi-causatives, let and make. One might imagine maybe that these things really are just spelling, English-style spelling out of causative morphemes, which attach to a verb, which are all over the place. English tends to not use affixes to spell things out as words, but these things could be affixes. So it could be that let and make are just the causative affixes attached to the bare verb. Then comes an interesting question. Why should perception verbs have the same property? But putting that on the shelf, if they all have this property, what you might expect is that all of these are pair-merged to the bare verb. And the pair-merged element is just immune to the passive operation. Say, whatever you think passive is, maybe dropping case, let's say. So that would fill in the gap, making use of the pair-merge device. There are other interesting proposals. One of them is Hisa Kitahara's suggestion about what has always been a pretty serious problem, head raising. Head raising has none of the right properties. It violates the extension condition. It's always described incorrectly. If a verb raises to inflection, say to T, it's always described as if it's a T, but it's not, it's a V. The thing somehow that's adjoined is really verbal, not inflectional. And the further move of V to C is really kind of a V-second phenomenon, not a T-second phenomenon. So there's all kind of problems. Another kind of problem with it is it's sort of, head raising has properties that are kind of shared, that cross syntax and phonology. So it's almost entirely like phonological processes in that it doesn't have semantic consequences. So whether you raise, take Jean-Yves Pollock's analysis of French and English, which many of you know, if you raise in French, you tend to raise the verb, in English not to raise it, but the semantics doesn't change. If you have a V-second language, it has the same semantic properties as a non-V-second language. And in fact, you have to look very hard, way out at the fringes, to find some kind of semantic consequences to head raising. That makes it look phonological, but the trouble is it's successive cyclic, which makes it look syntactic. So it's kind of problematic all along. But the real question is, how do you get around this? How can you actually create it without violating all the rules? Well, Hissa's proposal is this. Essentially, we'll just take the T to C case, but the same for the others. You generate and then DP. You generate C, then that's just ordinary. It's not even generate. C is in the workspace because that's where the lexicon is. So you just look at it. It's there in the workspace. Then you merge these two, pair merge them. C, T. We now have a set. The workspace now contains this and this. Notice by merging C and T, you haven't increased the number of accessible elements because neither of these is accessible. Okay, that was, as we've already pointed out, they're just like old man, either is accessible. So, and once you've done this, you now simply merge this thing to that. That gives you the right answer. And if you think about it, you can do all the head raising that way. I thought for a while that there were some problems about this. Hissa and I corresponded about it, but I think the problems are easily overcome. So that's a possible way of approaching the entire problem of head raising, which has been a tricky and serious problem. So I'll leave it in your hands to play around with that and see if you can handle the rest of head raising that way. But it's a simple way to proceed, which doesn't violate any of the rules, doesn't add accessible elements, just follows all. It's just available. You don't have to invent anything new for it. And it's crucially has to be pair merge, for one thing, because that's the way these things end up. They end up as adjuncts, not as sets. And secondly, it doesn't add accessible items, so it doesn't violate the resource constraint. So it has the right properties in that respect. Well, there's plenty of questions like this. There's a lot of, a major task that is faced is to take all of the cases that, two tasks. And first one, take the cases that have been described usefully by illegitimate operations. So take all the cases that have been handled by, say, late merge, which is very widely used, or by parallel merge, which gives you all the multidimensionality cases and so on. Now take that whole class of cases and show how you can handle them by legitimate operations. I gave a couple of examples last time, like ATB, parasitic gaps, but do it for the whole slew of them. And of course, the broader task is take a look at that massive data out there and see if you can make some sense out of it. That's we now have a criterion for what make sense means. Make sense means get a genuine explanation, where a genuine explanation means one that's that can be that meets the conditions, the crucial conditions of learnability and evolvability. And if you can reduce it to merge, you've solved that problem, because there's no question of learnability, and the problem of evolvability, as I mentioned, is basically solved. You have to look at the details of how it worked, but we know it happened, okay? So if you can get to that, you have a genuine explanation. If you can reduce things to pair merge, you've come pretty close. You still have to ask the question of how pair merge could have evolved, but at least that's an easier question than lots of other things you can imagine. We would then like to try to show that the other devices that seem critical for explaining things, like, say, phase theory, can be reduced to third factor properties of minimal computation. They do, in fact, reduce computation. So if you could show that that's another third factor condition like resource restriction, you'll have a genuine explanation. That's the general project. But notice it, and it's again clear, should be clearer, going back to my first lecture, that this project only arises if you accept a particular version of what the whole enterprise of linguistics is. If you pick a particular kind of answer to the initial question, what is language? What are we doing? The answer is the enterprise is one that attempts to deal with, to address what I called earlier the Galilean challenge, the challenge that was posed at the beginning of the scientific revolution, which translates in our terms into capturing the basic property of language, the property of that each of the faculty of language permits the generation of an infinite number of structured expressions with semantic interpretations and the option of ancillary operation of mapping it to one or another sensory motor condition. If you accept that project and then a particular variant of that project, which not all people who do generative grammar accept, the second variant is to assume that this is part of natural science, okay? In other words, follow what's called the biolinguistic program. Take this property to be a property of human beings, not some object out in the external world, which somehow magically human beings connect with, but just an actual property of human beings. Then you have to meet the conditions of evolvability and learnability. Then we have the notion of genuine explanation. Then all this mass of questions arises, often with solutions, often not. Notice again that not accepting this enterprise is perfectly legitimate. It's a way of describing things in ways which might be very useful. It's also useful for engineering projects, kind of Silicon Valley linguistics, where you don't really try to explain it, just get something that works. Lots of interesting things you can do. But this is a very specific approach to language, saying it's part of natural science. It's trying to meet the Galilean challenge. If that's the enterprise, then these are the kind of questions that arise. Well, there's another topic that I ought to at least mention. There's not much time for it, which is just left out entirely. A computational system has rules and atoms, things that are the smallest elements of the computation. I mentioned earlier that if you have merge and a one-element lexicon, just one thing in the lexicon, one atom, then in fact internal merge gives you the successor function. And I showed some reasons to think that that's a natural outcome. But in any event, there've got to be atoms. And I haven't said anything about those. So what are the atoms of computation? And right at this point, we're moving to a domain that I really didn't talk about, namely the general domain of semantics. So how does the domain of semantics fit into this enterprise? Well, here you have to be a little careful. You have to ask what you mean by semantics. There's a classical notion, actually goes way back in history, but in the modern period, it's Frege, Charles Sanders Peirce, Tarski, Carnap, Quine, that tradition. This concept of semantics has basically two essential notions. One is the notion truth and reference, which are essentially the same thing. And the other is the notion entailment, with many variants. So let's take a look at those two notions. First of all, the notion entailment is not semantics, it's syntax, okay? It's called logical syntax. Entailment is a matter of the formal relations among expressions. The world doesn't even have to exist, okay? Semantics is the field that tries to relate the internal mental computations to the world, the actual real world out there. That's semantics. That's truth and reference. But entailment is logical syntax. And if you look at what's called formal semantics, which is some of the richest and most exciting work going on in the field in the last couple of decades, notice it's all syntax. It's all pure syntax. And it's an interesting kind of syntax. It's sort of analogous to phonology. If you think about the externalization process, what do we have? The syntax generates a set of objects. We then want to externalize it. And that process of externalization has two steps. The first, it's called, traditionally morphophonemics or phonology, in the sense that, say, Morris Halle and I use the term, but it's the mapping of the syntactic structures to some sort of phonetic form. The phonetic form is a syntactic object, of course, and the mapping is it's a symbolic manipulation. So it's, again, syntax in the general sense. It's a particular part of syntax. I should say that this task of mapping, what generative phonology, mapping syntactic structures to phonetic form, has pretty much been abandoned in modern phonology. Contemporary phonology is mostly optimality theory, and that simply doesn't look at this question, okay? It deals with other questions. But this question of generative phonology, which was in fact the first thing that was discussed back in the late 40s, early 50s, has been pretty much forgotten. But it's there, it's a problem that has to be solved if you are concerned with externalization, with how language gets out there to be sounds or signs. So one task, which is really part of syntax, is generative phonology, mapping syntactic objects to, say, narrow phonetics. Then there's another task, and that is taking the narrow phonetics and telling us how it relates to motions of the articulators or to sound waves, or if you happen to be doing sign, how your gestures end up actually being formed. How do you move your fingers and so on. That's phonetics, acoustic and articulatory phonetics. If you go back to semantics, formal semantics is like phonology. It's syntactic operations setting the stage, you hope, for eventual relation to the outside world. Just as generative phonology is syntactic operations setting the stage for the phonetician to fill in how it relates to moving your articulators around, okay, which gets you to the outside world, something outside language. Well, this then comes the question, notice that of all of the domains of the study of language, it's almost all syntax. It's what we call kind of narrow syntax, just forming the syntactic objects, what I've been talking about the last couple of days. Another part of syntax is generative phonology. Another part of syntax is formal semantics. All of this stuff is going on inside the head, right? Doesn't get to the outside world. It's neither phonetics nor semantics. Of all of these areas, the area of formal semantics is different from the other two in the way it's been pursued, which raises interesting questions. It is the only domain that has not been subjected to the effort to find genuine explanations. So there's no effort within formal semantics to ask, what's the simplest way to do it? The problem is, let's just find a way to do it. You know, if you can get a way to do it by sticking in lots of lambdas and so on and so forth, okay, we'll do it that way. But the question of what's the best way to do it, the way that really gives explanations, that's really hasn't been raised. Now, that's not a criticism. It's a very hard question. And so if it's not been raised, well, hard questions often tend not to be raised. But one should remember that it's a question to be dealt with someday. As formal semantics develops, this branch of syntax develops, it should go the way of generative syntax and generative phonology. In the case of generative phonology, there's a lot of work on how to get the optimal way of doing it. In fact, that's what things like sound pattern of English are about, and plenty of other work. And narrow syntax is kind of stuff we've been talking about. Formal semantics, that part of syntax, the question really hasn't arisen. Sooner or later, it should arise. Another interesting aspect of formal semantics is it's kind of tacitly assumed to be invariant. So if you, there's no proposals that languages have parametric differences in how you interpret, say, quantifiers and variables. There's a way of doing it, and if you do it, that's universal, which is a very reasonable assumption. Because if you think about the things that are being investigated, there's absolutely no empirical evidence for them. A child has no evidence about any of them. So if you look at the literature and you look at the things that people are studying, they're totally without evidence. So either they're just not accurate, or if they're accurate, they're going to be universal. So it does make sense to say that this part of syntax is invariant. I've talked a little about whether narrow syntax is invariant. That's an open question. It doesn't look like it on the surface, but a lot of the work that's been done is kind of restricting the domain of variability of narrow syntax to the point where you might imagine that the core of narrow syntax, what's dealing with the Galilean challenge, the operations that are yielding the semantically interpreted objects, maybe that doesn't vary. That we don't know. It's an open question. If it doesn't vary at all, then the variability of language is entirely an externalization, where it certainly varies all over the map. Not any question there. I mean, it's not free. There's very interesting restrictions, but a lot of variation possible. So that's the kind of picture that seems to be emerging, I think, and it leaves open this thing here. Where does that fit in? How do we relate this stuff that's going on inside the head to the outside world? Turns out not to be such a simple question. In fact, if you look at the proposals in formal semantics, they sound as if they're relating to the outside world, but when you look at them, they're actually not. So it takes, say, model theoretic approaches. The elements of the model are sort of, one treats them as if they're actually out there. But in fact, if you look at the elements of the model, they're completely mental objects. there's nothing in the outside world that corresponds to those postulated objects of the model. So the model theoretic semantics works fine. You know, you can do all kind of things with it, study necessity, you know, so on and so forth, but it's all pure syntax. It's not getting to the outside world. What about event semantics, which is a very rich and productive field, the kind of neo-Davidsonian event semantics? Well, what are events? I mean, are events things in the world? Does the world come packaged in events? Actually, it doesn't. You know, events are our mental constructions imposed on whatever's going on. So events are really internal. And we know that to try to count the number of events that's going on is kind of meaningless. So, for example, thanks to Zeno, we know that if you walk across the room, there's a continuous, the number of events is the power of the continuum, okay, and same with anything else you're looking at. So there are about as many events as you decide to impose. So event semantics, which is very productive and rich, is, again, another form of syntax. So how do we get beyond syntax? Well, we have to look at the notion of reference. Truth will depend on reference. And if we want to look at the notion of reference, we start naturally by looking at the words that purport to refer. So you look at the literature on reference, mostly philosophical literature, say London is taken to be a prototypical referential word. A lot of problems arise, say Kripke's puzzles of belief, when you try to ask questions about London. But is London a thing in the outside world? Well, you can ask yourself. So, for example, I can tell you that I visited London before it was burned down and rebuilt 20 miles up the Thames. So is there an object in the real world which is physical, because it can be burned down, but then can be rebuilt somewhere else with different physical objects and looking differently? Is there such an object in the physical world, in the outside, in the material world? Certainly not. We could decide to rebuild Carthage, let's say. It was gone a couple thousand years ago. We could rebuild it somewhere else, look different, but it could be Carthage. So whatever these things are, they're not names of things in the outside world. What about other words? Are there, in fact, we might rest the question whether there are any words in language at all that refer to anything in the outside world. I think the answer is there aren't. Some of the reasons for this were given as far back as classical Greece. So, for example, Aristotle asked the question, what is a house? And his answer was, a house consists of the amalgam of two different kinds of elements. In his metaphysics, they're matter and form. So the matter of the house is the timbers, the bricks, the stuff it was made of. The form of the house is the design, what it's for, what the architect had in mind, how it's used, and so on. So something might look physically just like a house, but in fact be something totally different. It could be a library, let's say. It could be a garage, could be a paperweight for a giant, could be all kinds of things. It depends on what the architect had in mind and how it's used and what it's for, basically. But the properties of form are not in the physical world. They're in the mental world. Now, when Aristotle talked about this, this is, from his point of view, metaphysics. In fact, it's in his book, Metaphysics. But when you go to the 17th century again, there was a kind of a cognitive revolution And a lot of these ideas were reinterpreted in terms of modes of cognition, which I think is the right way to look at them. So reinterpreting it in those terms, a house is something that we construct in our minds, which has a material element, but of course the crucial part of it is what Aristotle called the form. That's something that's part of our mental operations. So when we use the word house, we're not referring to an object, and we're carrying out the act of referring, like I'm referring to that object over there, but the word house is not referring, okay? You think about every word in the language, it's exactly the same way. There's an example even earlier than Aristotle, the pre-Socratic example used by Heraclitus, who argued that you can't cross the same river twice, because when you cross it the second time, it's a completely different physical object, and you're a different physical object. So it's impossible to cross the same river twice. Of course, we do cross the same river twice, which simply tells us that our notion river does not refer to anything in the material world. It refers to a construction that we developed. And if you start playing around with how do you individuate these objects, becomes pretty tricky. So for example, take river again, say the Charles River, which I used to cross on the way to work up and back every day in Boston. Suppose you take the Charles River and you reverse the course of the water. It goes the opposite direction. Okay, you've still the Charles River. Suppose you divert it into a different direction, because you don't want it to go into the bay, but somewhere else. Still the Charles River. In fact, you can play around with it and make all sorts of massive changes in the physical object, and it'll still be the Charles River. On the other hand, there are trivial changes that will prevent it from being a river at all. So suppose you put barriers along the side, and you start using it for, say, commercial tankers going up and down. Now it's between 2 points. Then it's a canal. It's not a river anymore. Suppose you even make a more minuscule change. You make what in physics is called a phase change from the liquid to the glassy state. Tiny change, almost undetectable without instruments. But now it has a hard surface. And you paint a line down the middle and you start using it to commute to Boston. Okay, now it's a highway. You've made an almost undetectable change. If you play around with it some more, you can see that you can make huge changes in the physical object. It stays the Charles River. You can make virtually undetectable changes. It's not a river at all. Take a look at any other word in the language, you find it's pretty much the same. So it may be that language simply does not have the concept of truth and reference at all, which means it doesn't have semantics. There is no semantics. There's syntax and there's modes of using the objects you've constructed, roughly what's called pragmatics. It could turn out that the whole study of language reduces to syntax and pragmatics, with syntax having these many different variants. In fact, my guess is that's probably what we're going to find when we pursue the topic further. That raises many very interesting questions. So for example, take these terms like house or river, London, whatever you like. Where do they come from? If we look at animal symbolic systems, a very striking feature of them is that the atoms of these systems, the elements within them, do in fact pick out identifiable physical events. Okay, so you take the bee that has my name attached to it. If it's a honey bee and does the right sorts of things, then it's it does the famous waggle dance. It flies out to a flower, comes back to the hive, waggles, and the things that it's doing are one-to-one identified with particular physical phenomena extraneous to the bee. The distance to the flower, the height of the flower, the orientation in which you have to fly, the quality of the flower, and so on. Every animal system we know is like that. Monkey calls, for example, if there's something we call a warning call, what it means is the leaves are fluttering in a certain way, the monkey reflexively emits some noise, other monkeys run away, maybe an eagle's coming, something like that. Animal systems seem to be like this completely. The human systems are not like this at all. That raises a very interesting question. Another one of those mysteries. Where did this come from? And if you look at the array of mysterious things, there are plenty of them, and they fall into a couple of categories, two categories. One category is the category of mysteries where we just can't get the right kind of evidence because it's just empirically impossible for us to do it. We can't go back, say, 200,000 years and hear what people were saying. In principle, yeah, it's an empirically possible. It's a theoretically possible task, but you just can't do it. That's one kind of mystery. But then there's the deeper kinds of mysteries, which have to do with things like selecting the sequence given by the Hilbert epsilon operator when you're trying to form a coordination, or more generally, just picking what sentence you're going to produce. And these kinds of mysteries are the kind where you really don't even have bad ideas. There's no idea as to how to proceed. Those, we could ask what that category of mysteries is like, could mean it's some restriction on human cognitive capacities. There's a lot of debate about this. Most scientists vigorously reject the idea that there could be a limit on cognitive capacities. But if you think about it, it's a strange position. If humans are similar or part of the organic world, not, say, angels, we ought to have the same properties as other kinds of organisms in some respects. Every organism we know has scope of cognitive capacity and limits of cognitive capacity. And in fact, the two are kind of logically related. Whatever is yielding the scope is also imposing certain limits. And you might ask why humans should be exempt from this. I'll leave that with you as another project.
So I hope the former phonologists and semanticists in the audience who are now syntacticians will have questions. May the questions begin. Yes, here in the front. Down here. Down here. Yep, the mic is coming.
Well, first of all, thank you so much. And I would like to ask you, considering all this fascinating theory, how could you define madness for us?
Define?
Madness.
Ah.
In Portuguese, loucura.
Given what you have said so far, could you define madness?
And I could go, I would like to go a little further and ask you, what could you say about these writers? I'm thinking in people like Samuel Beckett or Antonin Artaud, the French one, whose texts are always dealing with disturbing syntax.
With disturbing syntax?
Yeah.
Okay.
Literature.
Would you maybe also like to comment on Samuel Beckett, or the second author was?
Antonin Artaud.
Antonin Artaud, whose writings are about disturbing syntax?
Yes, no, not about, but whose writing are always really disturbing syntax.
Oh, okay.
Thank
Well,
you.
you know, a good bit of creative literature makes use of the properties of language, but purposely distorts them to impose tasks for the reader. So if you read, say, serious literary criticism, say, a book like William Empson's Seven Types of Ambiguity, which is a kind of a famous work of the 1950s, Empson argues that poetry, in particular, he said, is designed to have actually a completely minimal use of language to impose on the reader the task of creating interpretations and using the reader's imaginative resources to reconstruct what's not presented in the text. So poetry would be different from, say, a literal description, which tells you everything that's happening, because it's calling on the reader to create and invent. If you go back further to classical aesthetic theory, like Schlegel, for example, who Coleridge borrowed from, we're familiar with this mostly from Coleridge, but it comes from Schlegel, that he argued that, he had an interesting argument that he argued that poetry was the most exalted of the arts. And he pointed out that when you talk about the poetic quality in music, you're talking about its imaginative character. When you talk about the musical quality of poetry, you're talking about something less significant, you know, the way it sounds or something. And then he asked the question, why should poetry have this special status? And he argued that every art form has some medium. So sculpture deals with marble, painting deals with colors. You know, each one has its medium. Poetry also has a medium, language. But language differs from the others in that it's inherently creative. It has an inherently creative aspect. That's the Galilean challenge again, recognized. It's got this capacity of creativity internally to it. So therefore, the art form that makes use of this modality will be uniquely creative, and in fact will be used in such a way as to draw from the reader, the hearer, the imaginative resources that are inherent in the medium itself. Now, when you get to, say, Samuel Beckett or literary artists in general, they're playing with this all the time, for trying to compel the reader to think and create and imagine. I wouldn't call it madness exactly, but although Plato did, Plato argued that it was recognized there's various levels of creativity. There's the kind of creativity that exists in, say, normal language use when you're kind of constantly creating. But there's a higher form of creativity that has this true aesthetic value, and Plato argued that that has a form of madness. So, okay.
Question over here?
Thank you. I would like to know what your perspective is about natural semantics, metalanguage, the approach that provides 64 words that are supposed to be semantic primes, and that provides a semantic foundation for universal grammar, or that might propose a foundation for that.
Yeah.
Do you have a comment on natural semantics,
Metalanguage.
which provides a meta-language of 64
Yeah, and
primitive
it has been
terms?
developed by Anna Vika and Godard in Australia.
Do you know the reference?
I don't, but I can repeat it again. It was by Godard and
Anna Verbika.
Anna Versika, Australian semantic.
Verbetska?
Yeah, yeah.
Oh, okay.
Yes,
I know her
yes.
work.
Verbika.
Well,
It's a Polish name. It's kind of
Yeah,
hard
oh
to
yeah, Anna
pronounce.
Verbitska, yeah.
well, I think it's interesting work. She's trying to find fundamental elements that appear in semantic systems generally. And it's, I'm not really very conversant with the work, but I've looked at it, and I think it's a, it's a promising, fruitful direction. She has some interesting insights. But it's an attempt to find, as I understand it, basic elements that that are constitutive of the systems of natural semantics in the world, which is a reasonable project. Yeah.
Over here. Gabe in the red shirt.
Hi. So it seems like one of the main philosophical motivations for positing an externalist notion of reference is that you need that in order to get some notion of objective truth. So when I make claims about London, say, I'm not just expressing some perspective I have on the world, I'm making a claim which can be independently evaluated as true or false. Do you think that this sort of internalist notion of reference that you have, is there a way of reconstructing objective truth, or are we kind of condemned to have a merely subjective notion?
Yeah, I heard that. I mean, it's true. If I'm talking about London, if I say, take the sentence I gave as an example. Suppose I say again something like this. I visited London last year before it was burned down by a fire and was rebuilt 20 miles up the Thames. That's a statement that can be evaluated. But the question is there a physical entity identifiable in the outside world that I'm picking out? And I don't think there is. I'm talking about the world, undoubtedly. There is what Aristotle called a material element. So, it's 20 miles up, not 50 miles up. It was this place that people lived in. Now it's some totally different place. It's still London, meaning what the criteria of individuation and identification are in fact mental conditions. But notice that shouldn't surprise us too much, because that's true of cognition in general. We don't have what's called immediate experience is already constructed by the mind. There is sensory stimulation hitting your retina, but that's not what you experience. What you experience depends on what were called in the 17th century modes of cognition, ways of interpreting the data. That's immediate experience. So the most immediate experience we have, the most we're most confident about and certain about, is already constructed. Whatever is objective is something we postulate. We hope that there is a real world out there which is somehow giving us the data that we experience. But what that real world is, for that we go to the physicists, and they have some very strange answers. So, for example, you go to the Institute for Advanced Study and talk to the late John Wheeler, a great physicist. For him, the world consisted of answers to questions that we pose. That's what he called it from bit. There's no world at all. We just ask questions, we get answers. That's the world. Okay, if that's what he says, fine. I can't argue with him. But whatever it is, it's something we postulate. It's not something we experience. So in fact, if the words we used to refer also have this property, it shouldn't really surprise us that much. We are different from other organisms in that respect, one of the many respects.
From Gabe to Gabe.
Another game. They say that a picture is worth 1,000 words. Let me stand up. But we might say that picture entails 1,000 sentences. And your picture of entailment is as a kind of syntactic relationship. But in this kind of case, we have a relationship between domains that have very different syntaxes. And so I'm curious about what is your general view of entailment, co-reference, other kinds of apparent semantic relations that obtain between representational modalities.
I don't know that I can do justice.
Entailment.
Here,
I heard
let me give a
entailment
one-sentence
co-reference.
version.
Sorry,
What is if entailment is syntactic, how do we entail from vision to language?
if entailment is syntactic, how do we entail from vision to language?
Well, that's not entailment, that's inference, which is something quite different. So entailment is a formal relation among syntactic objects. You know, you take a look at quantification theory. It tells you how this syntactic object relates to that syntactic object. Inference is an act that we carry out, very mysterious act. We face problems. There's something out there that's puzzling, you know. Why does across-the-board deletion work, let's say? And then you somehow construct a theoretical idea, which you then try to ask, does this account for the basic properties of the data? Nobody knows how that works. If you take a course if you're, say, studying physics at UCLA, I'm pretty sure there isn't a course on methodology. There might be in the sociology department, but it's very unlikely to find one in the physics or the chemistry department, because there is no method. It's just something that you manage to do somehow. Some people do it better than others, but nobody knows how it's done. This actually relates to a concept that I just was using as if it's straightforward and neutral, but it isn't. That's descriptive adequacy. So one of the things we want to do in studying linguistics is to make sure that our explanations meet the condition of descriptive adequacy. At least we get the facts right. But that's a very complex notion. What's descriptive adequacy? I mean, it's not just all the data you have around. For one thing, the data that are out there are not pure data. They're not data that specifically come from the particular source that you're trying to investigate. That's why scientists do experiments instead of just, cataloging things that go on in the world. The reason every experiment is a high-level abstraction. Each experiment is a very complex abstraction, theory-driven, which says, I'm going to throw away lots of stuff that's going on and look at this particular thing, because I think somehow this particular thing bears on an explanation of what might be going on in the world. That's the most elementary part of science. It's already trying to abstract away from all the noise out there and seeing what might be useful for explaining something. And those things are the properties of inference. But the way you learn how to do that in the sciences is just by watching other people do it. You say, here's the way it was done, I'll see if I can do that myself. But there's nothing you can't teach it, You can't teach how to carry out successful inference. You learn it the way a carpenter learns his craft, by watching skilled artisans do it, and you sort of pick it up. But I think that's about all that one can say about inference. I mean, of course, there's, philosophical discussion of it, but you have to be really cautious about the discussion. So, for example, one of the ideas that scientists commonly use is the notion of Popper's notion of falsifiability. So if you have a theory that can be falsified, it's real, and if you get a negative result, you throw the theory out. every scientist knows you never do that. If you get data that falsifies your theory, what you usually do is say, well, I'll put it on the shelf. Maybe somebody will figure out what's wrong with it. But if the theory looks good, I don't care if it's falsified. You know, and if you look at the history of science, that happens all the time on crucial cases. You know, so these things, they're kind of rules of thumb, but they don't really work. That's not the way scientific inquiry is done, or rational inquiry in any area. You know, not just natural sciences. The sciences are the best place to look because it's most refined. You know, there you really have deep results and so on. You learn how things are done, but it's part of just ordinary life constantly.
The woman in the purple shirt you had asked earlier.
Hello, I just had a clarification question, probably I misunderstood. So it is with dealing, how we dealt with head raising over there up on the board. So I just wanted to clarify that the pair.
Just one, a question about head raising
Oh,
that you
yeah.
had over here on the board.
Yeah, so my question was the pair and head raising, is it the set CT and set TVP, or is it C and the set TVP? Because if it's CT,
Can you repeat that, please?
Yeah.
Is it
the pairs in the head raising case, T2C case, is it the set CT and TVP, or is it C and the set TVP?
I didn't hear you precisely, but the question was that when you were discussing head raising and you had the set
VP.
TVP.
Yeah, which then further raises to C. So the new set formed is CT, or is the set formed as C along with TVP?
Is the new set that is formed C along with TVP?
No, just T. Okay. Actually, if you want to get the right answer, the source of this is sitting right here. So if I'm not giving the answer correctly, you fix it. But I think the idea is you have TVP.
Yeah.
You've got C inside the lexicon.
Mm-hmm.
So you take C and T, form the pair CT. That's just some new thing out there. You haven't added accessibility because both of the elements are inaccessible. Now that you have CT sitting out there and you have the old TVP, you can just merge them. And that gives you the thing you're trying to end up with.
Okay, so how is it exactly different from external merge then?
How exactly is it different from external merge in that case?
It's not.
Parallel merge, sorry. My bad.
Well,
How is it different from parallel merge?
From parallel, well, that's an interesting question. Like, why can't you, that's one of the problems that he and I have been corresponding about for a while. So you could imagine that after you've constructed CT, TVP, you start off somewhere else and you construct some other TVP, and then you take this CT and you stick it onto that. That would be an illegitimate operation. But the question, and I thought for a while that was a serious objection to this, but on reflection, I don't really think it is, because what you're getting that way is something you can always produce. And it's illegitimate because you're just getting a case where the T that you have up there is trying to be a copy of something down below, but it isn't. It's just a repetition of it. So it's just something that's incoherent. And you could always do that. You could, not quite apart from this operation, after you've constructed TVP, you could make up some other thing, XP, and just merge that on, and it would be nonsense. So you can always construct nonsense. And I think this would just end up being a particular form of nonsense. Notice that there's a subtle difference between the illegitimate, we do want the system to generate non-grammatical constructions, but we don't want it to generate things that violate linguistic principles. That's quite different. There's quite a distinct thing. Like, take, say, negative polarity items. things like, say, ever. You can't say John was ever here, but you can say, I doubt that John was ever here. But notice that in order to generate, I doubt that John was ever here, you first have to generate John was ever here. So we certainly want to allow the system to generate ungrammatical sentences. Otherwise, we can't get grammatical sentences. And in fact, we're perfectly happy to have the system generate things like metaphors that deviate from normal argument structure. Phrases like misery loves company, for example, which violate the selectional restrictions of the verb. We want lots of things like that. But we don't want the system to generate things like the books is on the table, or a violation of island constraints. That's a crucial difference. Not a very, in many ways, not a very clear one. You have to think about it, but that distinction just has to be there. And this kind of case that you're suggesting would be one in which you're essentially creating something nonsensical, but not violating linguistic principles, as distinct from parallel merge, which does. It's a subtle but interesting distinction.
Okay. Omar, over here. Well, okay. Down here.
Thanks. I really enjoyed these lectures, and I just wanted to ask you a general question about the linguistic enterprise. Namely, what role, if any, do you see for the study of language change in informing our understanding of the
Language
language
change.
Yes.
What role does language change?
What role does the study of language
study of
change
language.
play in increasing our understanding of language in general?
Quite a lot. I mean, languages don't change in arbitrary ways. They change in very specific ways. And by looking at the kinds of ways in which language change, we get evidence about what the system is like. What are the dimensions in which language can change and which it can't change? And what kinds of phenomena could cause that change? Notice this is very similar to the study of language acquisition. We're asking how bits of data that come around lead to modifications of the system that's in the mind. The language acquisition does it in one way, language change does it another way. So it's a probe into the structure of the system that you're investigating. What kind of things can happen, what can't happen, what makes them happen, what doesn't have an effect, and so on. Whether it's language acquisition or language change or a dialect, things like what's the name for it? When you're mixing pieces of one dialect into another, I forgot the name for it. That also tells you things that can happen in certain ways, not other ways. Lots of ways of studying the system. You have a complex system, you perturb it in all sorts of different ways, you learn things.
Over here. Silence.
Hi. My question is about you saying that truth and reference are essentially the same thing. Because while we were listening to the lecture and doing the Q&A, everyone's taking notes in these really different ways. Reference. I'm actually taking notes in 3 different ways. I have an AI app transcribing everything using an NLP. Then I have this kind of like Joseph Novak concept map of my own stuff. And I'm also texting my friends like, oh my God, Noam Chomsky said truth and reference. It's basically the same thing. So why are they not exactly the same thing? Why did you say they are essentially the same thing? And yeah, that sentence was like,
She was intrigued by your statement that that truth and reference are essentially the same thing, and she asks, she says she's familiar with 3 very different kinds of reference, but she wonders why you didn't say they're exactly the same thing. Or maybe you want to elaborate on that issue.
Well, you know, a theory of truth says typically, I have a name and a predicate, and the name refers to an object out there, and the predicate either does or doesn't apply to that object, and if it does apply, the statement subject predicate is true. So if I say, you know, the sun is in the sky, the idea is the sun refers to a particular object, that's reference. In the sky is a certain property. My statement, the sun is in the sky, is true, just in case that property holds of the object. For language, that doesn't really work. For the sciences, it does work, but it does work by stipulation. When you're a scientist, what you're doing is constructing, inventing concepts which do, you hope, have the property of reference. So when a linguist develops the concept phoneme, let's say, they're saying, I hope that there's something in the external world that this concept refers to. If a physicist defines electron, say, they're saying, I hope there's a thing out there that this one-to-one refers to, okay? So scientists are essentially trying to construct systems that do meet the referential criterion and therefore will be producing true or false sentences, which can be evaluated by, you know, by experiment or observation. But ordinary language just doesn't work like that. All the concepts that we have involve complicated interactions between what Aristotle called form and matter. You know, just fact about natural language. In contrast, animal communication systems seem pretty close to that. Of course, they don't make true statements. I mean, you know, the bee who's waggling is not trying to make a true statement. He's just doing whatever the internal structure of the bee is telling him to do. Okay.
Professor Mahadra down here. The mic is coming.
So can we go back and maybe get a little bit of expansion on what you went through yesterday on ATB?
ATB?
Yeah.
Why don't we let that go till tomorrow, because
Okay.
it's a long story, okay? And then, it's important.